Hello everyone, welcome to lesson 221, day 1, transformations of other functions. Our goals today are to understand what a parent function is. We also want to learn how to write the graphing form of different types of functions such as absolute value functions, square root functions, cubic functions, and rational functions. So the entire last 2 weeks we have spent learning about transformations of quadratics, specifically graphs that make parabolas. And now we're going to be looking at other types of functions and other shapes of graphs. We also want to understand what a locator point is, and we want to be able to write the equation of a function in graphing form giving its graph or description. All right. So let's start on this. All right, so we've got several different types of functions out there besides parabolas that we need to be able to identify transformations with. So I've made a table here to quickly summarize the different types of graphs that we might encounter, the different types of functions that we have. And it's important that we associate the shape of a graph with its name and its graphing form. Okay, so in this first one we see a V shape. So this is different than a parabola because it actually has a point here rather than a curved smooth bottom. All right, so and this point is very much like a vertex here, so this is what we call an absolute value function. All right, and it is created by functions of this form where we have the absolute value bars in here. Now this row called a parent function, what they're describing here is this graph that you see up here at the top. This is what an absolute value function looks like before I do anything to it. So before I do any horizontal shifting, vertical shifting, stretching, or reflecting, this is what the absolute value function looks like. It's the most basic form. All right, but then we go and we do stuff to it. We want to move it around. We want to reflect it. We want to stretch it. We want to do things to it. And this is what it looks like after we've done that stuff, right? So this is what we call our graphing form. And you'll recognize many pieces of this. A, H, and K are back, okay? And they all represent the same thing. The A value still represents the stretch. The H value still represents our left and right movement. And the K value still represents our up and down movement. And just like before, if I want to reflect this, right, if I wanted to make this V open downwards like that, then I would need to put a negative in front of the A value. Okay. So this next one is called a rational function. We've seen these before because we investigated the asymptotes of these things, right? So we've seen this shape of graph before. We call these rational functions, and its most basic form before we do any kind of transformations on it is 1 over x. This is the parent function. Okay. Then when we do stuff to it, this is what it looks like, right? So we put the stretch factor in the top, right, where the 1 was. The left and right movement is going to go in the bottom of the fraction with the x. And then the up and down movement is going to be a plus or minus some number on the outside of the fraction. So it'll be separate from the fraction over here. All right. This next one is a cubic function. So this one has kind of a weird shape, but it's got this little inflection point here. So it goes up and then it kind of flattens a little bit and then it goes back up. All right. You might also see cubic functions that look like this, right, where that inflection point is no longer flat, so it kind of goes up, then back down, then back up. So it kind of looks like that as well. So this is the most basic cubic function there is. This is y equals x cubed. And then obviously this is going to look very familiar. It almost looks exactly the same as a quadratic. The only difference here is the 3 versus a 2. But all of the parts are the same. Okay. This last one is a square root function. It looks like half of a parabola on its side, right? So it's got this curve that kind of goes up and then flattens out a little bit as it goes off towards infinity over here. And it is its most basic form is y equals the square root of x. So before we do anything to it, this is what the parent function looks like. And then after we do stuff, here it is, right? So the A goes on the outside or in front of the square root here. That is our stretch factor. And then the horizontal shift is going to go inside the square root with the x. And the vertical shift will be outside the square root here with the k. All right, so that's kind of a very basic breakdown of each of those functions. And you have them all right there in one place so that you can study those very easily. Now, this next thing that we're going to talk about is what's called a locator point, and this is a point on the graph which gives the position of a graph with respect to its horizontal and vertical shift. Okay, so in other words, it gives you the h and the k values, and each of these graphs up here has a locator point, and I already gave you the locator point for the absolute value function, right? So the locator point is going to be the vertex here, or the pointy part of the v, right? This is called our locator point. And since these are all the most basic graphs, all of these are going to be located at 0, 0. Okay. Now the rational function, the locator point, is actually the intersection of the asymptotes. Okay, so we would draw in our asymptotes, and the locator point is located right here on the origin at 0, 0. So you might want to note these on your notes or in your notebook, wherever you are keeping this information. But you're going to want these locator points later on to do certain problems. Okay, you need to be able to find these locator points to write the equation. Okay, so this is the locator point for a rational function. The locator point for a cubic is located right here, and this is called the point of inflection for a cubic function, but it's right there where it flattens out. Okay, and I'll draw an arrow to that, so that is our locator point there. I cannot write. There we go. And then on the square root function, the locator point is where the function begins or ends, however you want to look at it, but it is essentially at this stopping point right here when that curve starts to go down. All right, so this is our locator point for a square root function. And like I said, all of them are located at the point 0, 0 right now, because none of these graphs have been moved around. None of them have been stretched or had anything done to them. These are all the graphs of the parent functions that I described here. Okay. All right. So let's take a look at some of the types of problems that we might do. Okay, so perhaps I might give you an equation like we see here, and we see some equations, and I want you to describe the transformations that have occurred if I were to give you the equation. Okay, so if I were looking at this one, I would instantly be able to tell you this is an absolute value function because of the absolute value bars that we see in the function. And then based on our table up here, right, if I'm looking at the graphing form of my absolute value function, I can see where my a, h, and k are located. So this value right here, this -3, tells me two things. One, it's been reflected. So it's been reflected over the x-axis, and it has been stretched. And I'm just going to abbreviate here, vertically stretched by a factor of 3. Okay, so I get two transformations just from the a value out front. Now I move inside of the absolute value, and I look at my graphing form up here. I know that value inside of the absolute value bars. That is my horizontal shift, and since it has been minus, or since it has a -2, that tells me that it's been shifted right 2. Remember, it is still opposite, just like with the quadratic. And then I go to the last piece here. This +4 on the end is my k value, which tells me my vertical shift. So this has been shifted up 4. And this would be a description of all the transformations that occurred to this function. Okay. Now I'm going to come over here and I'm going to do the same thing with this one, and I recognize right away this is a rational function. I can tell because of the fraction bar here. So this is a rational function, and I'm going to go through and I'm going to locate my a value, which is supposed to be the top number of the fraction here. So I see a 2. There's no negative in front of it, so there's no reflection like there was in the first one, but the 2 does tell me it has been vertically stretched because it should normally be a 1. Right? So if it's a number bigger than 1, it's been vertically stretched. So this has been vertically stretched by a factor of 2. Okay. Then I come down here, the number in the bottom of the fraction with the x, that is our horizontal shift. So that is telling me a +4, which means it has been shifted to the left 4. And then the -5 on the end of the fraction is our k value, so this has been shifted down 5. Here we go. Okay. One more here. This one is a square root function, so we're looking at this one right here. Okay? And I can tell my a value is located on or in front of the square root here. So this one has a negative, and I don't know why I put an equal sign there. But let's start with that negative, which tells me it has been reflected over the x-axis. Okay. It also tells me that it has been compressed, right? So this is a number in between 0 and 1. So this is not like the first one where we had a 3 and a 2. Those are numbers that are bigger than 1. This one is smaller than 1 and in between 0 and 1. So this is a compression. So this has been compressed by a factor of 0.5. So this should all seem very familiar to you. It's almost no different than what we were doing with the parabolas, right? Just different shapes of graphs. All right, so moving inside of the square root, we see the -6, that's our horizontal shift. So this has been shifted right 6. There we go. And then our last transformation comes from the k value on the outside, so this has been shifted up 2. And there we go. Okay. So very familiar type of work, right? It's just different types of functions, but the same thing that we've been doing for the last 2 weeks. All right, now I copied the table down here for us again because this time we're going to go the other direction. I'm going to give you the verbal description, and I want you to write the equation. And we're going to do this the same way that we did with quadratics before. We're going to start by writing the basic graphing form or the blueprint for whatever type of function they describe. So you'll notice in this one, it says a cubic function, right? So I'm looking for the cubic function, that's this one right here, and I'm going to start by just writing that graphing form out. So I've got a parentheses x minus h to the third power this time plus k. And then I start reading my clues, and I'm going to start filling in the blanks, right? A, h, and k are the 3 things that I need to figure out. So it tells me it has been reflected over the x-axis. So if this has been reflected, I know that I'm going to need a negative. It has been shifted to the left 4 units. Okay, no problem. Well, the shift left 4 units goes here where the h is, and if I want to shift left 4, I need a plus 4 to the third power. It has been shifted up 3 units. That's going to go here for the k, so I need a plus 3 on the end. And it has been compressed by a factor of 1/6. Well, that tells me what the a value is, right? It was compressed by a factor of 1/6, so I need 1/6 to be in front of the parentheses here. And that completes my equation. Now going over here, we have a different function. This one says a rational function, so I'm going to be writing something that looks like this. All right, so I'm going to start with my blueprint. So I've got y equals a over x minus h plus k. All right, so I'm going to be filling in the blanks here for a, h, and k. I'm going to go y equals. It says it has been shifted to the right 8 units, so my horizontal shift is here where the h is. Okay, so I'm going to start this, and I'm going to say x, and since it's been shifted to the right, I need a minus 8 here in the bottom. It says it has been shifted down 4 units, so they just gave me my k value, so I know on the end here I'm going to have a minus 4. And then it says it has been vertically stretched by a factor of 4. So normally I would have a 1 up here at the top, but since it's been stretched by a factor of 4, I'm going to replace the 1 with 4. And that completes my equation. Now notice in this one there has not been a reflection, so I would not put a negative in front of the 4 here. I'm going to leave the 4 as a positive 4. All right. Last set of problems here says write the equation of the following graphs. No problem. And this is where understanding the locator point and the shape of the graph becomes very important. You'll notice this shape, right? This resembles the shape of a cubic, right? So this is the one where it kind of goes up and flattens out and then continues back up. And this is what we call a point of inflection. So those are all my clues that tells me this is a cubic function, and I'm going to be writing a function that looks like this. Okay, so I have to figure out my a, h, and k values just like I did in the previous problem. Now if I read the instructions carefully, it says that I can assume all stretch factors are either 1 or -1. Okay, so if I need to determine if this has been reflected. Now this is why I gave you the shapes of the parent graphs up here, and I want to go back and take a look at those specifically for the cubic. This is the most basic function before it's been reflected, before it's been moved. And notice here on the left, see how this end goes down and this end goes up? If it had been reflected, right, this end would then be up here, and this end would be down here. So this would be going up, and this would be going down. So it'd be opposite if it had been reflected. All right, so I'm going to go back down here and see which direction they're going. Okay. So it's going down on the left and up on the right, which means it has not been reflected. So that means that A value is going to be a positive 1. Then I'm going to worry about my H and K values. All right, and I can get my H and K values from the locator point that they give me here. Remember, the locator point gives us the H and K values. So since this is a positive 2, that means that the locator point moved from 0 to the right 2. So to move to the right 2, I need an x minus 2. And then it moved down 1 unit. So to move down 1, I would need to subtract 1, and that's what I'm going to put in for my k value. So this represents the equation of the cubic that I see in the graph. Let's try this one. This one, if I'm looking at the shape, resembles a square root function. So you would go back to that table that I gave you on the front page. You would look for a shape that is similar to this one. You'll notice that it's similar to the square root function. That's how I know to grab this blueprint. So this is what my equation is going to look like when I'm done. But I need to find these three things, A, H, and K, by looking at the graph. So let's go look at that graph. So there is my graph. This is my parent graph. Now notice how it's going up like this. So this is before any reflection, stretches, or horizontal or vertical shifts. So it would normally open up. If it had been reflected, it would be opening down. So let's see if it's been reflected. It is going down, so it has been reflected. So I'm going to need a -1 in front of my square root. Now notice the locator point is located right here, and they give me the coordinate of that locator point, which tells me my H and my K values. So this tells me that the function, which would normally start at 0, 0, has been shifted to the right 1 unit. To shift to the right 1 unit, we need an x minus 1. And that minus 1 will be inside of the square root. It has also been shifted up 2 units. So to get it to shift up 2 units, I would have to add 2. And that completes my equation. Alright guys, that is the end of the video. Hopefully you found that helpful. If you have questions, make sure you let me know in the Zoom chat. Have a great day.